Above all, life's major driver is the energy we receive from the sun. As the Earth rotates over 24 hours, the planet responds to the incredible power of the sun, our local star. Each day, more than 1 million terawatts, over 7,000 times our global energy consumption, strike Earth. This triggers a wave of activity around the globe. At dawn, plants on land and plankton at sea begin to photosynthesize and grow. At the same time, sunlight drives wind and weather around the globe. We are also a part of this cycle as our bodies respond to the daily inflow of energy from above. Our skin cells use sunlight to create essential vitamins. Even the flight paths of planes reveal our intimate relationship with the rhythms of day and night. Aircraft travel west in the morning to extend the day and east in the evening to reduce the night. But while the sun nurtures all life on Earth, it also has the power to destroy. And with the help of a very different kind of satellite, we are coming to understand just how great a threat it can pose. Orbiting 22,000 miles above the Earth is the Solar Dynamics Observatory. This satellite looks not at the Earth, but away from it. Its task is to observe the radiation released by the sun, what scientists call space weather.
We have this wonder of the sun and where space weather is born.
These striking images are produced by the SDO's ultraviolet sensor, detecting light frequencies beyond the blue end of the visible spectrum. The sun emits constant light, heat, and other forms of radiation, along with occasional dangerous bursts of charged particles.
Most people don't realize that the Earth is exposed to from the sun at about 1 million miles an hour.
Sometimes a massive pulse of those charged particles erupts from the sun's surface. It's called a coronal mass ejection, and it contains billions of tons of charged particles, superheated to tens of millions of degrees, and blasted out at millions of miles per hour. It has the potential to wreak havoc on our planet. This supercomputer visualization shows what happens when a coronal mass ejection occurs. The explosion is equivalent to 14 million Hiroshima bombs. It sends a cloud of charged particles millions of miles wide racing towards Earth. Without some kind of protection, these enormous blasts would strip away the atmosphere, destroy our fragile ecosystems, and scorch the Earth. Over time, repeated coronal mass ejections would even cause the oceans to dry up, leaving behind a planet as barren and bleak as Mars. Fortunately, the Earth has an invisible shield, a magnetic field that satellites are now enabling us to better understand. Orbiting between 40 and 120,000 miles above the Earth, NASA has a network of satellites called THEMIS. Each is equipped with highly sensitive instruments that can detect the strength of magnetic fields.
Themis is a series of variations in the magnetic fields.
This computer model, using Themis data, shows how an invisible magnetic force field called the magnetosphere protects the Earth. It's generated by the rotation of the Earth's core.
Themis allows us to build an overall picture.
Themis reveals how the magnetic field is constantly blasted by the sun. The wave of charged particles, called the solar wind, distorts the magnetosphere into a gigantic teardrop shape, 120,000 miles across. As wave after wave of solar particles strike the outer magnetosphere, most are deflected. But when a coronal mass ejection arrives, it tears open the magnetosphere, allowing a vast number of charged particles to breach the magnetic field's first layer. The particles are free to rush in towards the planet, but the Earth has a second line of defense. Inner magnetic fields steer the radiation down towards the poles.
This process is extremely energetic. Particles along the magnetic field lines towards the polar regions.
The radiation streams downward, encircling both the north and south poles, and triggers something we can see with our own eyes, one of nature's true wonders, the northern and southern lights, or the aurora. As the radiation strikes the upper atmosphere at extreme speed, it excites the air molecules. This makes them glow. The oxygen in the air radiates red and green, the nitrogen red and blue.
These charged particles in the atmosphere causing these beautiful colors. So when we're looking at the aurora, basically we're looking.
The aurora is a vivid reminder of how potentially lethal energy from the sun is dissipated in the upper atmosphere. The Earth's magnetic field has shielded the planet from the sun's deadly radiation for billions of years, enabling life to take hold and flourish.